So today we're going to have a look at how to do different operations with surds. You're going to start by doing these 4 questions, which involves multiplication, division, addition and subtraction. And then we'll look at a more deeper question where we'll try and apply these rules and see how that goes. So firstly, if we want to multiply surds, it's literally like normal multiplication. So we're going to do root 18 times root 2, and we'll just do 18 times 2. And 18 times 2 is 36, so therefore we would get root 18 times root 2 would give us root 36. Now we know that 36 is a square number, and therefore root 36 is the same as 6. So our answer in a simplified form would be 6. Then when it comes to dividing, we do the same thing again. So division, it doesn't matter if there's a surd there, you do normal division. So you're going to do 42 divide by 6, and that gives us 7. So it'll just be root 7 here. So root 42 divided by root 6, root 7. Simple as that. Now when it comes to addition and subtraction, things get a little bit more complicated. Here, you can't just do 48 add 16. That's not how it works with addition for surds and subtraction. You have to put it in a form where the root, so the surd, is the same for both of them. So you have to think, okay, I've got root 48 and I've got root 16. What can I do that would give me the same root for both of them? And you think of factors that multiply together to give you that root. So for example, 48, I know that root 12 and root 4, when I multiply them, that will give me root 48. So that's 2 factors that I can split the root 48 into. And then I know that root 16, I can do root 4 and root 4. And that would also give me root 16 as well. So those are some ways, and now we can see we can try and get the root the same for both of them and try and add them together. So you can have a look at root 4. Well, that we know is going to go down to 2. So that's essentially, we've got 2 root 4 plus we've got root 12 and another root 4 here. Now this one here, root 12, again we can see if we can simplify it a little bit further. So root 12 we know can be simplified into we've got root 3 and root 4, and then obviously we know this root 4 is a 2, and even this root 4 is a 2 as well. So 2 times 2 gives us 4, plus we've got now this root 4 as well here, which gives us 2. 2 times 2, 4, so 4 root 3 there. And now, because we don't have a root here, we can't add this anymore. Like it has to stay as this. It can't be 4 root 3 added to the 4 itself. It can't be 8 root 3, for example, because there's no root 3 here. So the final answer, therefore, would just be 4 plus 4 root 3. Okay. Then if we have a look at the subtraction one, so again, a similar thing with subtraction, you have to make sure that the surds are the same. So here what we could do is try some other numbers. So for example, with root 108, I can try root 12 and root 9. So I know that that gives me 108, and then root 9 you can simplify that to 3. So we've got 3 root 12 there. And then root 48, again we can do 12 and we can do root 4 there as well. So then the root 4 goes down to 2, so that's the same as 2 root 12 there. So we've got this as follows. So we've got a 3 root 12 and minus that from 2 root 12, which if we take it away, that gives us 1 root 12. And technically you can simplify that. So 1 root 12, you can go for the root 12, you can have root 4 and root 3, and then the 4 becomes a 2 because square root of 4 is 2, and then the root 3. So it can be simplified in the most simplest way would be 2 root 3, and then that would be the answer. Okay, so now let's have a look at this question. So here it says they want us to simplify 2 brackets and they want their answer in a specific form, in a plus b root 18, where a and b are integers. So integers basically means whole numbers. That's what we're after. and we've been given a way, this bit to start from, that we're going to start by expanding. So we'll start off by writing this out. We've got 7 plus 2 root 50, and then 5 minus 2 root 2. So what you want to do in expand brackets, you always do this term multiplied by here, this term by that, this one by this, and that by that. So this is kind of what we're always looking for when we try to multiply the brackets. So you start by doing 7 times 5, that gives us 35. Then 7 times minus 2 root 2, which is minus 14 root 2. Then 2 root 50 times 5, which is 10 root 50. And then 2 root 50 times minus 2 root 2, which is minus 4 root 100. So we've got that all multiplied out, and now we're looking for ways to simplify. We know that root 100 can be simplified to 10 because root 100 is just 10. So that bit is minus 4 times 10. That's what that bit becomes. And so we've got minus 40 at this point here. That would be minus 40. So then 35 minus 40 gives me minus 5. Then we've got all of our minus 14 root 2 plus 10 root 50. Now we want to put the root 50 in a way so that we have both the surds the same. So root 50 we can do root 25 times 2 gives us 50, right? So then we can say that that would become, so root 25 we know is 5. 5 times 10 is 50. So that then simplifies to 50 root 2. And so we have minus 5 minus 14 root 2 plus 50 root 2. If we do that, we get minus 5 plus 36 root 2. And then again, because we need it in the format root 18, we need to figure out a way to put this in root 18. So we can simplify 36 into 12 times 3 gives us 36. So 12 times 3 root 2. Then we can do, then we can basically say, okay, so we've got the 3, that if it was written as a root would be root 9. So it's essentially saying root 9 times root 2, that's the bit that gives us root 18. So that bit will give us root 18. We'll have our 12 there as well, so 12 root 18, and then our minus 5. So all together, your final answer would therefore be minus 5 plus 12 root 18. And that is then given in the format where you've got a and b as your integers, so minus 5 is a, and b is 12, and then root 18 is the format that they wanted it in. Hope that helped. Thank you for watching.